In this video, we're going to take a look at the ChromaDB vector database, and this is an open source AI application database, and as you can see here, it's got 14,000 stars on GitHub, so it's a very popular open source vector database. And ChromaDB can enable applications such as storing embeddings, vector search, document storage, and more. So ChromaDB, it's an open source vector database and it has client libraries for Python and JavaScript. And this is a very good tool to build applications around large language models. So we're going to dive in this video and we're going to create a ChromaDB database. And we're going to create some collections in that database with some vectorized data. And we're then going to provide queries to the database in order to find the most similar documents in ChromaDB to the query that we provide. So we're going to do that in this video. So let's dive in. Before we do, don't forget to give the video a thumbs up if you're enjoying this content. And we also have a Ko-fi page in the description if you want to support the channel. So let's get started, and we're going to go to the documentation for ChromaDB. And let's start with this page here, and there'll be a link to this in the description as well. So Chroma is an AI native open source vector database, and Chroma makes it easy to build applications based around large language models. And if we scroll down here, you can see that Chroma gives you the tools to store embeddings and metadata in the database. It comes natively with the ability to embed or create vectors based on documents and queries. And you can also search across these embeddings and find the most similar documents to the query embedding. Now, Chroma prioritizes simplicity and developer productivity, and it's also very fast. So it's going to be very efficient when you're performing these searches across the vectors in the database. Now, Chroma can run as a server, but it also provides first-party Python and JavaScript SDKs. In this video, we're going to use Python. So we're going to use the pip install ChromaDB command, and we're going to start there. I'm going to open Anaconda prompt and bring that onto the screen, and I'm going to paste that command in there, and we're going to install ChromaDB. Now, I've installed this using Anaconda so that I can use ChromaDB within a Jupyter notebook, and you can verify the installation has worked by running the import ChromaDB statement in Python. And if you don't get an error, that means that ChromaDB has been installed successfully. So let's get started. I'm going to go back to the ChromaDB documentation. Now, we've already installed the package for Python. What we're going to do now is create what's called a client object. So we can copy this line of code here and go back to the Jupyter notebook. And in the cell below here, I'm going to create a variable called Chroma client. And what we do here is instantiate a client object. And that client gives us a way to interact with the underlying ChromaDB database. Once we have a client, what we can do is call methods such as this one here. It's called create collection. And collections, as it says here, these are where you're going to store your embeddings, your documents, as well as any additional metadata. So I'm going to copy this code here and I'm going to paste it into the cell just below the client. And let's call the collection that we're going to create just documents. So we're using that client, which has a method called create collection. When we execute that query, we get back the collection in this variable here, and we can then execute different commands, different instructions on the collection itself, as we're going to see very soon. Now, if we execute this cell again, we're going to get back an error because we already have a collection called documents. So as well as create collection, there's another method here that we can use, and that's the get or create collection. So that gives us a way to retrieve the collection if it already exists. And if it doesn't exist, it will create the collection. Now, what we want to do when we have a collection is we want to add documents to that collection. So what we're going to do in the cell below here is we're going to use this collection, and it has a method called add. Now, if we go back to the documentation, we're going to see how to do this. So the collection.add method takes some documents. That's a list in Python containing the text-based documents. And it also takes the IDs for each one of the documents. So you can see here we have 2 documents and 2 IDs for each one of them. Now, there are additional options we can pass to add. We're going to see that later on. But let's just copy this code for now, and I'm going to go back to the cell and we're going to paste it in here. So we have 2 documents. One is about a pineapple and one is about oranges, and each of these has an ID. Let's execute this query, and what we're going to see here is that ChromaDB is actually downloading what is the default embedding model, and that model is this one here. It's called 𝗤𝗵𝗽𝗁 So this is going to happen the very first time that you try to use ChromaDB. It's going to download the vector model, the embedding model, and this is the default model that's used to turn each of these documents into a vector. So every document you pass to the add method is going to be turned into an embedding. And that embedding is going to be stored in this collection alongside the document that it refers to. Now just to illustrate that, just while it's downloading, I think it might have finished now actually, but let's go to the documentation anyway. And I'm going to go to the guides section on the sidebar. And this is a useful page. We're going to go through some of that later, but there's a concept section on the left, and we're going to look at the embeddings page here. And if you don't know what embeddings are, they are an AI native way to represent data, and it represents data using vectors of numbers. So you can represent text data as well as images, audio and video as vectors. And there are many options for creating these embeddings. You can have an installed library locally, which has a model that you can use to turn, for example, text into vectors, or you can call an API, as we're going to see later in the video. Now later we're going to call the OpenAI embedding APIs, but for now we're going to stick to that default model that's been downloaded. So if we go down here, you can see this model, some detail about this. This is the default, and this is a sentence transformer model. And what that does is it creates embeddings from sentences and documents. And this can be used for a wide variety of tasks, as it says. If you want to know more about this, you can click the link that's provided here, and that's going to take you to some documentation for this particular embedding model. We're not going to do that in this video, but I'll leave a link to this page in the description. If we go back now to what we were on before here, and that was the getting started page, I'm going to go down here after we've added our documents. What we're going to do is query the collection. Now remember, when we actually added these documents, it was going to use that default model, and it's going to create a vector embedding for each of the documents. We can now use the collection.query method. So I'm going to go to the cell below here, collection.query, and we can pass in a couple of keyword arguments to that as specified here. So I'm just going to copy this, and actually let's just copy the entire code here and go back to the Jupyter notebook. And I'm going to paste that in here. So we get a variable back called results when we call the query method. And what we provide to this is the query texts. So we provide a Python list of any query texts that we want to pass in, and Chroma will automatically embed that. So it's going to create the embedding from the query text. And then after it's done that, it's going to return n number of results as you specify here. So we have an n results parameter that tells us how many results we want. And importantly, the results that we get back here are going to be the n most similar documents in our collection to the query that we're passing in. And that similarity is computed by taking the embedding for the query text and comparing that to all of the vectors that we have, or the embeddings that we have in the collection, and finding the most similar vectors. In other words, the vectors that have the smallest distance to the query vector. So let's execute this, and we get back the results here. In order to see these better, what I'm going to do is import from Python's pprint module the pprint function, and that stands for pretty print. We can then use that function here, and it's going to print this out in a way that's a bit easier to read. So what we have here is the two documents that we added to our collection, one about the pineapple, one about the orange. And we also have the two IDs here, ID1 and ID2, for each of those documents. Now we don't have any metadata because we didn't specify that when it was added, but what we do have here are some distances. So the first document here about the pineapple has this distance here, and the second one about the oranges has a distance that's greater. Now the idea is that the smaller the distance, the more similar the document is to the embedding that was created for the query text. Now the query text mentions Hawaii, and it makes sense that that might be more similar to the text containing pineapple than the one containing oranges. Now if we change the number of results to 1, it's going to return a single document, and it's the one about the pineapple. And that means that we can find very easily the document that we have in this collection that's most similar to the input query. So I think that's the important thing to understand about collection.query. It's going to return the most similar documents to the embeddings that have been created for the input queries. Now we can also pass filters to the query method. So what I'm going to do here is add another keyword argument to the query function, and that is a keyword argument called where_document. And we can set that to a dictionary in Python. The key for the dictionary is going to be a lookup, and I'm going to use the contains lookup. And we want to get documents that contain the word pineapple. So when we perform this query, we can filter down the documents in the underlying collection to only those that contain a certain keyword, in this case pineapple. And if I specify the number of results to be 2 here, we're going to see that we don't get back 2 results because, of course, there is only one document here that contains the search query pineapple. If we comment this out and do the normal query, we get back both of the documents. So not only can we query to get the most similar vectors, but we can also perform filters here based on some parameters that we provide in a dictionary. And I'm going to go to the Chroma documentation, and on the right hand sidebar on this page here, we have a section on using where filters. So Chroma supports filtering queries by metadata and document contents, and you use the where filter to filter by metadata and the where document filter to filter by your document contents. So some examples of these types of filtering operations include equality, inequality, greater than, less than, and so on. And there's more if we look at document contents. For example, contains and not contains. We use the contains expression, but you can also use other ones here, as you can see. And by using this expression, such as where document, that's going to operate like a where clause in a normal SQL query, and that allows you to filter the underlying collection. Now let's move on. What we're going to do now is we're going to get some data from an external source, and that's going to be a real-life data set, and we're going to read that into our ChromaDB vector database. Now in the next video, what I want to do is take what we're about to do, and that's creating a vector database with embeddings. We're going to take that and we're actually going to create an application around that using the Streamlit package in Python. For now though, what I want to do is go to this site here. This is kaggle.com, and I'm just going to grab some news articles here, but you can actually grab any text-based data set and you can download that and then place it into the directory that we're working in, and that's the one that contains the Jupyter Notebook, and then read that into your application. Now if you want to use this one, I've got a link to that in the description of the video, and you can download that at the top right of the page. That's going to download that. You can then place the archive directory into your local directory where the Jupyter Notebook is running, and you can extract that, and then you have this CSV file here. It's called articles.csv. What we're going to do is go back to Jupyter Notebook, and we're going to read this into a variable. So what I'm going to do for now is just remove this code, and let's get some space here. And I'm going to read this in using the polars package. And we did some videos on polars recently, and that should be appearing on the screen now. Let's create a variable here called articles, and we're going to call polars.readCSV. And I'm going to pass a link to that file. So it was in the archive directory, and it was a file called articles.csv. Now, if you're using the same dataset as me, you also need to pass an encoding in order to read this properly. And the encoding is this one here. It's ISO 88591. So that's going to read the CSV data into a polars data frame. We can view the head of that data frame using dataframe.head function, and you can see some of these articles here. So there's 4 columns, one for the article, one for the date, one for the heading, and one for the news type. We're mostly interested in the article in this video, and that contains the actual text for the news article. We're going to take that text and we're going to create an embedding based on that text using the OpenAI embedding model. Now there's one other thing I want to do here. I want to get a row number for each of these articles, and we're going to use that as the document's ID in the ChromaDB collection. So in polars, there's a method we can call on a data frame, and that's the withRowIndex method. And we're going to pass an offset of 1 to that. And let's just see what that gives us back. So now you can see on the left hand side a new column in this data frame, and that's an index column that contains a number for each of the rows in the data frame. Now, what we could do here is we could take each of these articles and we could store it in the ChromaDB using that collection.add method that we saw earlier. And that's going to use the default embeddings, that model that was downloaded when we ran that method earlier on. But in this example, I want to use an embedding model from OpenAI. So I'm going to go to the Chroma documentation and we're going to look at the integrations page. And there's various different integrations, as you can see here, for external platforms. We're going to look at the OpenAI one in this video. So Chroma provides a convenient wrapper around OpenAI's embedding API. Now note this important point, the embedding function will run remotely on the OpenAI server, and you need an API key in order to actually call that API. You can get that by signing up at OpenAI here. So what I'm going to do is go to the OpenAI console. So I'm on the OpenAI console here, and I'm on the page to create project API keys. And these have replaced user API keys. And as you can see here, I'm just going to make the text bigger. OpenAI will recommend that you use project-based API keys going forward. Now we can create this very easily using this button here. So I'm going to give it a name of Chroma key. And I'm just going to create this just now. And it's going to give us back that secret key that we can then copy, and we can bring that into our application. So I'm going to open Jupyter Notebook, and I'm going to store that in a variable called key. And I'm going to delete this after the video, so don't try and copy that. And then if we go back to the OpenAI page on ChromaDB, you can see the following OpenAI embedding models are supported. The 𝗬𝗓002 model, and we have a couple of text embedding 3 models, one's small and one is large. And the embedding 3 models, these are the most recent, the most cutting edge models that OpenAI has for embedding text. So if we open this documentation here, you can see that in this alert. The text embedding 3 small and large models, they are the newest and most performant embedding models, and they also have lower costs, which might be important if you're calling this API a lot. So we're going to make sure that we use those in this video. So let's go back to the documentation. Now notice that the embedding function that's specified below here, that relies on the OpenAI Python package. So you need to install that. So you can do that with pip install OpenAI. So I'm going to copy that and I'm going to open the Anaconda prompt. And I'm going to paste the pip install command into this prompt here. And that's going to install the OpenAI package. And then what we can do is I'm just going to copy this code here and we're going to bring it back into the Jupyter notebook. So just underneath the key here, I'm going to paste that code in. And we're going to replace this string that we have here with the key that we've created above. And that contains our OpenAI key. So what's happening here is that we've imported an embedding functions module from chromadb.utils, and that contains a function called OpenAI embedding function. And all you need to pass to that is the API key that you have, as well as the model that you want to call on the OpenAI server. And we are specifying the text embedding 3 small model. So let's execute this, and we're going to get back nothing at the moment, but we have this variable here, and that's a function that we can now call, and we can pass text to that function, and it's going to create embeddings for that text. Now, one thing to note before we move on, this key here, you should not commit that to GitHub or GitLab or anything like that. Ideally, you should be reading this key in as an environment variable. I'm skipping that just to make this video a little bit shorter, but that should definitely not be read in directly as a string in your application. Now what I'm going to do now is look at the articles that we read into a Polar's data frame. So we have these articles here, and if we call the len function on that data frame, you can see we have 2,692 articles. Now in a real application, we would create embeddings for all of these articles and store them in ChromaDB, and that's going to allow us to recall them later on. And it's also going to allow us to compare query vectors to all of these articles in order to get the most similar. But I don't want to create these embeddings for all of these in this video because that's going to call the OpenAI embedding model 2,600 times. It might cost a bit of money, I'm not sure. So I'm going to call that embedding model on a subset of these articles. So I'm going to define a variable n here and set that to 50, and then we're going to set the articles to the top 50 or the first 50 of these. So we can take the Polar's data frame and we can index in here and get a slice of the first 50 of these articles. I'm going to execute that just to make sure that I don't call that OpenAI embedding endpoint with thousands of articles. What we can now do is take this OpenAI embedding function that we created and we can pass some vectors to that. In fact, before we do that, let's just make sure that we have these articles cut down to 50, and you can see the shape of 50 rows and 5 columns. So what we can do is take our embedding function here. Now we need to pass a list here of all of the texts that we want to embed. So I'm going to pass a list in here, and then we're going to reference the data frame, and we're going to get the article column from that data frame. And if we get the very first entry, that's going to give us back this here. So we can try executing this. And what we get back here is a vector from OpenAI. So from the list of articles that we've passed in, it's going to create a vector for each one of them, an embedding, and it's going to return those to us. And you can see that single embedding that we've got back here. So I'm going to do this again and store it in a variable called vectors. And what we want to do is we want to add this vector along with its associated article to the ChromaDB database. And we're going to do that in a new collection. So in the cell below here, I'm going to create a new collection called articles using that get or create collection function. So let's execute that. And then below that, we're going to call collection.add. And again, we're going to add some documents to this collection. So let's pass that in just now. So the very first document in the data was this one here. It was the articles data frame. We got the article out of that data frame, and it was the very first row in the data frame. So that was the documents. We're going to give it an ID as well. So IDs is going to be equal to an array. And let's just give it the ID of ID1 here. And then what we're also going to pass that we didn't pass before is some embeddings. And we're going to set that equal to the vectors that we got back from OpenAI when we passed this article to the OpenAI API. So that list of vectors for each article that we got back, we're going to set the embeddings keyword argument to that. And what we also could do is set some metadata here. I'm not going to do that, but what you could, for example, do is you could take the header from the data frame. If we scroll up here, the data frame has a column for the heading for the given news article. You could maybe set some metadata on each of the documents by using the metadata's keyword argument here. I'm not going to do that just to keep it simple, so let's remove that. And let's try executing this function now. So we've executed collection.add, and importantly, when you pass the embeddings explicitly, it's not going to run that default embedding model that we saw earlier. It's going to use the embeddings that you provide. So let's now have a closer look at this article that we've added to the collection. So if we index in there, you can see the article. And this is about a government that has decided to bring down public transport fares by 7%. Now I'm going to construct a query based on this article. So I'm going to copy that from the sidebar here, and I'm going to paste that in. So let's put in a generic query, public transport fares by 7%. I've just copied a bit of text here from the given article. And what we want to do is we want to query the collection to find the most similar articles. Obviously there's only one in there at the moment. We're going to add more in a second. But what we could do here is run collection.query. And what we need to pass into this is not only the text as we did before, but we actually need to create an embedding for this query because we're no longer using the default model. So I'm going to do that just above here. We're going to create a query embeddings variable. And we can create that, and we need to call this function again, which was OpenAI embedding function. That's the one we got back earlier on. And we're going to pass into that the query that we have above there about these transport fares. So when we call this, it's going to give us back an embedding for this query. And then to the query function here on the collection, what we can do is we can pass in not query texts as before, but query embeddings. And we're going to set that to what we got above here. So let's just paste that in. And we also can set the number of results as before. I'm going to set that to 1, and let me space these out so we can see that. So we've got a query, we've created an embedding using the OpenAI embedding function, and then we're calling the query method on our collection that contains all of our articles to find the article that has the most similarity to this query embedding. So let's execute this, and we get back the following. You can see the ID of the most similar article. Of course, it's the only one at the moment. And you can see the distance, it's quite small, it's below 1. And we also get back the document itself. So by calling query, it's going to take the query embeddings that we have, and it's going to compare them to all of the different vectors that we have in our collection and return the most similar. So let's now read in all 50 of the articles that we had. So what I'm going to do here is I'm going to go up to just below this. And let's refresh our memory here about the articles data frame. It's a data frame that contains 50 articles. We've already read the first one into our collection and generated that embedding. We're now going to get the embeddings for the other 49 and add them to the collection as well. So let's scroll up a bit here and go back to where we called the OpenAI embedding function. And what I'm going to do is get the articles that we want out of this embedding function. And we're going to pass these in. So above where we create the vectors, I'm going to paste this line of code in. And what we want to do now is not get the very first article, but we want to get the rest of the articles starting at the second one. So we can use this slicing notation to do that. And that's going to give us back all of the other articles that we can then convert to a list that I'm going to call here articles list. We can then pass that into our embedding function. And for each article in the list, it's going to create a vector embedding and return that to us here. So if I go to the cell below this now and we look at the length of the vectors, we should see that there's 49 of these vectors. That's 50 minus 1, and you can see that here. Now what I also want to do is I want to create a set of IDs for these articles. So I'm going to copy this line of code, and just below here where we had the length, I'm going to paste this in. So we want to get the index here, so I'm going to copy the name of that column, and we're going to get all of the indexes from 1 to the end of the data frame. If we look at what that gives us, you can see it gives us 2 up to, I think it should be 50 here. And we want to set an ID for each of those. Now, if we scroll down a bit here, we can see what we passed into the collection.add function. It's a string that contains ID and then the number of the index. So we're going to use a list comprehension to recreate this here. So we have this list of indexes here. What we're going to do is set a variable here called IDs, and that's going to be a list comprehension in Python. And we're going to take this list that we have here, and we're going to generate an F string in Python. And it's going to be ID, and I'm just going to call this X for each X in that list there. So if we look at the IDs below here, we should see that we have the strings ID2, ID3, and so on. So we've used that list comprehension to create those, and we're going to use that and pass it to the collection.add method here later in this video, very soon actually. So what we have now is we have an articles list and we have the vectors for that. And now we have the IDs for each of these articles when we add them to the ChromaDB collection. So we have the collection here, and we're going to add each of these documents to that along with the vector embeddings. So what I'm going to do, let's just remove this line of code, and we're going to go back to the collection.add method, and we're going to pass in as the documents something different here. So let's remove this, and we can copy the name of this articles list variable and pass that directly here to collection.add. And the IDs here, we can pass the list comprehension result that we got above for these IDs. So each of the articles is going to have the given ID, and it's also going to have the given vectors. The vectors were generated by taking the list of articles from 1 to the end, and we called that OpenAI embedding function to generate those embeddings. So we're passing them into collection.add. I'm going to try this out now, and we can run this function. And how do we know if it's worked or not? I'm going to call another method on the collection, and that's one we've not seen so far. That's the .count method. And you can now see we have 50 articles in the ChromaDB collection. So we can try our query again here. So we have this query about public transport fares. We create an embedding on that query, and then we are calling the collection.query function and passing the embedding in. And we want to get the most similar result. If we call this, we get back the same article that we had before, I think. It contains the text transport fares by 7%. But if we generate a different query, or let's try something else first actually. Let's say we want to get back 3 results. So the 3 most similar articles that we have in our vector database to the query. This time we get back 3 articles, and you can see the distances here. This is the most similar because it's got the smallest distance to the query vector in that vector space. But we also have 2 others here now, and if we look down, we can see the actual documents here for the 2nd and the 3rd article. And you can see again the content of the text here. It is somewhat similar. We're talking about petroleum products. We're talking about prices that are decreasing. We've got a text here of something that's fallen by 50%. So it's somewhat similar to what we've got in the query. And that's the beauty of these vector databases. Once you have the embeddings and once you've stored them in the database, it becomes quite easy to take a query, create the embedding from that query, and then pass it in and compare it to all of the results that you already have in the database to find the ones that are most similar. What I'm going to do now is just take a very random article. So I'm going to go up here to where we called collection.count, and let's look at article number 23 here. And this one here, again, it's about the price of petrol and petroleum products. What I can do below that is create a new query here. So I'm going to replace these 2 lines of code. So we have a new query, what's the deal with the price of petrol? And we're going to pass that query in a list here to the OpenAI embedding function. That's going to give us back a vector for that particular query based on OpenAI's models. And then again, we're going to call collection.query, passing the embedding in, and let's get the 3, or in fact, let's say the 2 most similar results. When we execute that, we get back this. So we have different document IDs than we had before. So this one has got number 39 and 24. Our query was, what's the deal with the price of petrol? And you can see this kind of text reflected in the documents that have been returned. And the one below here is the actual source document that we looked at to generate that query. Lots of talk about the price of petroleum and petrol products. So we took a query here, very simple, that was generated based on what we looked at in the dataset. We passed it to the embedding model, but we are getting very similar results when we call collection.query and pass in that query embedding. So in a nutshell, we can take a query and we can find similar articles that are stored in our vector database that we have in our corpus. And this works because ChromaDB, the vector database, is going to compare the embedding vector with the vectors that it has stored in the given collection. And it's going to find the most similar articles to the query because the most similar are going to have the smallest distance to the query vector. So under the hood here, there's a similarity function that's used to compare vectors. You can also think of that as a distance function. And for example, it might use the cosine distance. Now, we're not going to go into that in this video. What I want to do just to finish the video is look at one final part of the Chroma documentation. Now, so far, if we go right back to the top of this Jupyter notebook, everything we have done here has been done through the ChromaDB client object, but there are other types of clients available in ChromaDB. This one is entirely in memory at the moment, so nothing that we've done here, all of the embeddings that we've generated and stored in the ChromaDB collections, none of that's actually going to be persisted. So if this program crashed or the computer turned off, then all of that is going to be lost. So sometimes we might want to persist this data to disk, And of course, if we're running a production application, we're going to want to do that. So what I'm going to do is go back to the ChromaDB documentation, and I'm going to go to the guides section here, and we're going to look at some of these. So when we import ChromaDB, as well as a client, we have the notion of a persistent client object. And that can be used to save and load the database from the local file system on your machine. So what I'm going to do here is copy the name of this persistent client and go back to the top here. And what we can do is change client to persistent client. And I think we provide a path to that. So let's do that just now. We have a path keyword argument, and in the current directory, I'm going to create a folder called vector_db. So we're naming where we're going to store the actual database files on disk. Let's execute that. And then if we create the documents collection and add a couple of documents here, if we go back to the directory here, you can see that as well as the notebook that we've been working with, we now have a folder called vector_db, and that contains the data that we've stored in the database. And you can see also a Chroma.SQLite3 file. And that's an interesting point to note, that Chroma uses SQLite under the hood. But basically, when we use this persistent client that we have here, it's going to store the data on disk in a persistent manner so that you can then save the data that you have in your database and then recall it later on. And that's of course vital for production applications. Now, as well as that, the very last thing to show in this video is that you can also run Chroma in client server mode. So let's go through that a little bit. When you run in that mode, the Chroma client is going to connect to a Chroma server that's running in a separate process. So in order to run a Chroma server, you can run this on the command line. It's the Chroma run command, and you provide it the path to your database directory. Once you've run that, you have a server running ChromaDB. You can then use the Chroma HTTP client to connect to that server, and you specify the host, and if you're running locally, that's going to be localhost, as well as a port number in order to connect to the Chroma server. And using this client server approach, that's probably going to be the way that you run ChromaDB in production. You'll deploy ChromaDB to a server, and then you'll use a client to connect to that, and that's going to be the HTTP client, and you'll connect to that remotely in order to use the vector database. And as well as the HTTP client, we also have an async HTTP client you can use as well. So that's all for this video. In this video, we have used ChromaDB, and we've created some collections, and we've stored some documents in that collection using the collection.add method. And once you've done that, once you've got documents in your collection and you've created embeddings, and you can do this either using the default models or using an external model such as OpenAI, you can then, if we scroll down here, call methods such as collection.query and pass in query texts or embeddings, and then the ChromaDB database is going to give you back the most similar documents to the given query. And this can be important if you're working with LLMs. For example, if you're doing retrieval augmented generation, you might want to find the most similar context that you have in your vector database and pass that along with your queries to a large language model. And if you're interested in a future video, we could dive into that and also build out a Streamlit application based around the vector database. If you have any suggestions for content, let me know in the comments. But that's all for this video. Thank you for watching. If you've enjoyed the video, give it a thumbs up and subscribe to the channel. And we have a Ko-fi link in the description if you want to support the channel. That would be greatly appreciated as well. Thanks again, and we'll see you in the next video.